this fall, as I've mentioned in previous weeks, I really wanted to highlight organizations and individuals that are kind of redesigning communities or structures to kind of be more attuned to the health of individuals that are interacting with those structures and with the environment as well. And I think that we're going to see a little bit of that and how to design with nature in this talk, which would be really cool. So with that, Katelyn, it's all you.
Thanks. My lecture is looking at architectural survival in an extreme environment, specifically for Antarctica. So just a bit of background. I'm from here in Vermont originally. Graduated from Mount Mansfield Union High School in Jericho, Vermont. And I started out at Vermont Technical College and then went to the Frank Lloyd Wright School of Architecture, where I focused on vernacular architecture. So architecture that reacts to its endemic environment. That borders on sustainable design a bit. And from there, to become an architect, you have to have an accredited degree. And I went to the University of Hawaii, who has a doctorate of architecture program. And I took my background in vernacular architecture and hope and desire to create buildings that are more attuned to users' needs, focused on environmental psychology, biophilic design, and feng shui, and did my doctoral research on that. Practiced architecture back here in Vermont for 4 years before I went back for a second doctorate, as you do. And this time I wanted to focus on that biophilic design portion because that's the least flushed out of those 3 branches of study. So it had the most potential. And it lined up more with my background with vernacular architecture. And I have a desire and a passion and a love for historical architecture. So I wanted to take biophilic design as a mechanism to analyze existing buildings so that we can move forward in a more cognizant manner from being informed. That needed to be narrowed down. Antarctica provided that basis. It's a shorter time period, a lot less buildings, and with a PhD, you have to have unique research, and Antarctica does that. There's only 4 other researchers in the world who have looked at the architecture of Antarctica. So that's how I came to study architecture in Antarctica. I have not been there yet. I have hopes. I've been up north of the Arctic Circle in Svalbard, Norway, and down to Tierra del Fuego, the tip of South America, with my research for this, but unfortunately I did not actually make it down to Antarctica. Hopefully soon. So just some background on biophilic design. So biophilic design comes from this term biophilia, which was first coined by Fromm from a sociological point of view. And his idea of biophilia was the love of life. Just pure, simple, break down that word into its 2 parts, love of life. It was then later adopted by E.O. Wilson, initially touching on it in his concept of sociobiology. And this was the use of evolution that's being described through social behavioral patterns. This was not well received at the time. However, his subsequent publication, entitled Biophilia, has been more well received and was a springboard for a lot of other research. So his interpretation of biophilia is humans' innate attraction to nature. That as humans, we, no matter where we live, we pattern our lives after connections to nature and trying to strive for those deeper connections. With Stephen Kellert, Wilson developed the biophilia hypothesis, and Kellert later took on with a multidisciplinary study the concept of biophilic design. So this uses the built environment as a mechanism to encourage biophilia. And this is where we start bordering on ecological and sustainable practices, because now we're looking at our love of nature as an impetus to help preserve or save nature. And so a lot of these building practices that connect us to nature also foster that sustainable aspect. So biophilic design. Kellert initially broke this down into a number of elements: natural patterns and processes, light and space, shape and form, and all of those then were broken down into individual attributes. 72 of them. And those are specific attributes of the built environment that can be used to help foster this connection with nature. And that in 2008 was what encompassed biophilic design, what Kellert laid out. And that was what I was proposing to use as my framework. 72 attributes is a little intimidating, and some of them do become a bit redundant. So I was thrilled when in 2018, Kellert developed a different publication where he simplified these down into more streamlined, broader topics. So especially the natural daylight, he brought a number of different attributes and simplified them just into natural daylighting that would have characteristics of 10 or 12 of his previous attributes. And this just became a much more feasible and comprehensible way of looking at biophilic design. These were then broken down into 3 experience types instead of elements. And so now we're looking at the direct connection to nature, the indirect connection to nature, and the sense of space and place. So Kellert isn't diminishing his initial ideas with biophilic design, but he's making them a little more flexible and a little easier to work with. Less like a checklist and more like guidelines of how to approach design. So that's a quick overview of biophilic design. And I'll get into some of the specifics with the analysis of my research. So the first question I always get is, are there buildings down there? Yes, this is a graphic that indicates where there are buildings as the circles get larger. It shows the indication of growth in certain areas. And you can see over the relatively short time period, the growth and the amount of structures that are constructed, and also the countries that have participated in this. Because we only made first sighting of landfall 200 years ago. So this does shorten things significantly, which was my goal with using Antarctica. Building-wise, the first significant phase is during the heroic age of exploration. That's the late 1800s up until 1922 with the death of Ernest Shackleton. This is when we had that push to achieve the South Pole, the race to the South Pole with Scott and Amundsen, with Shackleton and some other around the periphery. But also we have people just going down and discovering and mapping and exploring the continent in general. So not a lot is known. There isn't great technology at this time, and we're not quite sure how to approach this. We're still exploring. The next significant burst in building came around the International Geophysical Year, or IGY. And that was 1957 to 1958. Post-World War II, middle of the Cold War, and we're making a lot of significant scientific discoveries during World War II. So they were looking at how can we use this technology. And this was the anniversary of the previous 2 international polar years. So it made sense in this context, 57 to 58, to conduct it during that time. Technically, the IGY is the 3rd international polar year, but they expanded beyond the Arctic and the Antarctic to include Mount Everest and other extreme environments. So it got a broader title. What this meant was a more international focus on Antarctica, where during the heroic age, it was much more of a privileged European-centric development of buildings. There was one expedition from Japan and several planned expeditions from Chile and Argentina. I'm not sure if those went through, but primarily we were looking at European interest in Antarctica, and they divvied this up into different sovereignties. The International Geophysical Year was broader. We have stations cropping up for much more diverse, though still limited because of technology and the cost that it takes to mount these. They're also more military supported. So a lot of the structures were military temporary structures for extreme environments. And so they're more camp-like. And then the third one is the most recent, the 4th International Polar Year, which was in 2007 to 2008. So once again, working off our anniversary off of the other International Geophysical Years, we're 50 years after our IGY. And now we have much greater technology with more contemporary structures going up. And this didn't necessarily see the construction of new structures, but more the rehabilitation or replacement of existing structures with these sexy new buildings that were going up that are more space age. So from those 3 eras, I selected 6 case studies that are all on the continent of Antarctica, not looking at the surrounding islands. I also had a limitation that they had to be English speaking. I took Latin in high school. Has not been terribly useful for research, but it meant that I couldn't use any of the other research stations that didn't have resources in English. So I looked at British, Australian, United States, New Zealand, or if they had a significant base in English as well. What I ended up with for the heroic age was looking at Robert Falcon Scott's 2nd expedition when he did make it to the South Pole, did not make it back, but his Terra Nova hut, and then also Douglas Mawson of Australia at Mawson's huts. For the International Geophysical Year, looking at McMurdo Station, which is a US station, they're building 155, and also Australia's Casey Station, looking at their red shed. And then for the IPY, looking at the US's Amundsen Scott South Pole Station and the British Halley 6 station. So just to give you guys an idea of what these buildings look like and some information about them, going in chronological order, this is Scott's hut. It's in Cape Evans on Ross Island, and these were all intended as temporary structures. They were just there for their expedition, and what happened afterwards wasn't really their concern. They did leave it in good condition just in case someone had to use it in an emergency, which did happen with this, with Shackleton's later trans-Antarctic expedition. There was a group that accidentally got stranded here for a winter. But it was built in 1911. It had 25 men in it for that first summer. And your only access was through the sea. And it's just a very rudimentary, basic wooden shelter. It's nothing fancy. You've got your outhouses outside. Something you can see with the floor plan, it's pretty open. They did have some militaristic, because Scott was based in the military. So there's some militaristic where we've got separated by rank, that you've got the men's quarters versus the officers and the scientists' quarters. Even the outhouse was C at the time. And it was occupied for 2 winters. The second one was accidental. Similar to Scott, we shut it up when we left, hoping that, you know, whatever happens to it, happens to it. If someone needs it in an emergency, it's there. Mawson went back in the late 1920s and was surprised to find it still standing. It ended up that when they selected the site, it was on a rare calm day, and this was a site that was frequented by high winds, and they've recorded the highest wind speeds at sea level here. And so they did not have a pleasant winter, and you can see through most of the photographs that the whole structure pretty much got covered in snow, which helped as another added insulator. So this ended up being 2 prefabricated wooden structures that got put together. So you can see in the form that you've got these 2 pyramidal forms. Those initially were meant to be separate, but they've been squished together, which allowed them to have the living quarters separate from the working and scientific area. And then you have the surrounding veranda, which in a traditional Queenslander would allow in breezes while keeping the building shaded. But this added another layer of insulation with that air gap on the outside, and then the snow mounded on the outside of that. Jumping forward to McMurdo, and specifically building 155, this blue building. With these larger stations like McMurdo Station, which has a maximum capacity population of 1,200 people, it is the largest settlement in Antarctica. I focused on a building that was similar to the other, the huts and also the structures of the IPY, so that there was some commonality than just looking at the station as a whole. So this is located also on Ross Island, the same island as Scott's hut, but on Hut Point near Scott's initial station, or his initial hut, the Discovery Hut. As I said, it's the largest settlement in Antarctica. It's been growing since it was built in 1955. Even though there was more infrastructure in place, these were still initially considered temporary structures. It wasn't until the success of the International Geophysical Year that they started to put down more permanent roots and start to develop these more substantial buildings instead of more camp-like structures. So with building 155, we have the dormitory sleeping area. as well as the cafeteria and the lounge space for the people, for the occupants. The additional working areas and the scientific areas are in separate buildings. Now, a contrast between the IGY and the heroic age is we have people coming in by sea still and by having ships bring in supplies, occasionally people, but primarily we have airplanes bringing people in now. We have that technology. And then Casey Station with the red shed, obviously the red building. They didn't get too inventive with the name on that one. Originally, this was the location of a US station during the International Geophysical Year on Wilkes land. It was Wilkes Base. Australia was nervous with having some Russian bases happening underneath them in Antarctica. And so they wanted a buffer. They wanted the US to be a buffer between one of their stations and the Russians. And so the US put the Wilkes base there. Soon after the International Geophysical Year, they turned it over to the Australians. They abandoned their station, said, if you want it, here it is, it's yours. And the Australians took it over, and fairly quickly, they developed a new station as the existing buildings got buried in snow, which could not sustain the load and began breaking down. So they built what became known as RepStat, the replacement station. And at that point was when it changed its name to Casey Station. That one also, noble in its gestures, did not survive too long. And so they replaced that with what they've developed as the ANBUS building system, which is a modular building system that can be added and shrunk as needed. Generally, they're just adding on based on what they had learned through previous iterations. Casey Station is significantly smaller than McMurdo at 99 occupants. And you can see that's a much smaller footprint as well with less buildings. But similarly, the red shed houses all the recreational spaces as well as the living quarters and the eating and cooking, but they also have the medical facility within this building. Since this floor plan, they have added on, but I did not have access to those floor plans, so went with this one. And then getting to the more recent stations. The first one is Amundsen Scott. It's located at the geographic South Pole and named for the two men who initially made it to the South Pole. Amundsen beating out Scott by about a month, and Amundsen successfully making it back, where Scott perished on his way back. It's open year-round. That was one of the requirements for what I was looking for in a building, was that it had to be open year-round. It's only accessible by air, being in the middle of the continent. It's completely logical. It was initially built in 1957 for the International Geophysical Year. And that was a series of the little military structures that, with the drifting snow, soon became covered with snow and buried, and you had to take little tunnels down to them. The buildings were not designed to withstand that, so they developed a new station that had a dome over it, a geodesic dome. So that helped protect it. Figuring then the drifting snow could build up on that geodesic dome, and the buildings within it would be protected. That worked great, except for drifting snow does not create an equal load, and a geodesic dome happens to really like uniform load. And so the dome itself started to fail. And with the upcoming IPY needing to upgrade the infrastructure, the US Antarctic program worked with a firm, Ferraro Choi, out of Honolulu, Hawaii, and they developed this new design for Adamson Scott. Maximum capacity 153 people. It's got these two distinctive C-shaped modules. Initially, there were supposed to be 3, but budgetary cuts brought it down to 2. Now, with the newer stations, it's all inclusive. Everything is included in here. So once again, we've got our scientific and our work and our support spaces back within our building, along with our recreational housing, eating and cooking. So it's all contained within one structure. And one of these wings, I believe it's the second one from the left, the little offshoot down, it can be enclosed down to be its own independent unit. And so it's almost like, I've heard it described as a little life raft. So if something happened during the winter time, or during the summertime, but especially in the wintertime when it's inaccessible, you could, in theory, all evacuate to that little spot and wait it out until help could come. And my last case is Halley 6. As the name indicates, it has 5 predecessors. Now, I love all my cases equally, but this one is my favorite. Halley 6 is a significant departure, and this is where we see a shift in architecture in Antarctica. Adamson Scott was nudging that way, and Halley 6 took the ball and ran with it. You can see that it's very playful looking. It's much more space age. We've got different interiors, much brighter, more dynamic interiors. We have natural material. See that mobile. It can move. It's a series of module pods that can break apart and be towed to a new location. It can literally run away because this is on the Brunt ice shelf, and ice shelves get cracks. I have spent the last 3 years being worried that I'm going to wake up someday and my case study's fallen off into the ocean because it got cracked. The ice shelf got cracked. And within the first several years of it being built, 2 ice cracks began encroaching on it. And so this adorable little structure ran away. And unfortunately now, even though it's intended to be a year-round structure, it's only habitated during the summer months, just in case. They don't want something to happen in the wintertime. It can also climb itself up out of the snow. So Adamson Scott also had hydraulic legs, but it can only raise itself up a certain number of times before they're going to have to go in and do some infrastructure changes. Halley 6, though, with each of those legs, they can lift it up, shovel or plow snow under it, and then set the leg back down, do that for all 6, and then raise the whole pod up and do that uniformly until they're all climbed up out of the snow. Just kind of adorable. The maximum capacity, including housing that's not within the building, temporary summer structures, is 52. And this is my most recent one, built in 2012. So for this one, because it's broken down into little modules, I focused on the social module and also the 2 sleeping modules. The other ones, also similar to Adamson Scott, have our support systems and the scientific areas as well. So for my analysis, I took my 6 cases and I took Kellert's 25 attributes and analyzed what was available from my cases within these attributes. To do that, I looked at what Kellert considered examples of these attributes. So this ranged from colors to different types of building materials, different building practices, green roofs, gardens, different incorporations of ecosystems, biomimicry, simple things like artwork or windows, how transportation's occurring, how people are moving throughout the space, and different traditional approaches. So with that, I took the cases, crossed them with the attributes, and crossed them with the examples to show myself where the gaps were. And further with that, then trying to resolve, because there's a significant number of gaps, but what happens in Antarctica? Because there are significant, unique examples of how these buildings used different interpretations of those attributes. And so I took those and did a similar cross-analysis of the adaptations, examples, and opportunities. For example, if you think about lighting, for natural day lighting, Antarctica has a significant portion of the year that's 24-hour darkness, as well as 24-hour light. So an adaptation with the US stations, we have bedrooms that don't have windows, which to most of us is just incomprehensible. Just bedroom must have a window legally here in the US. But if it's 24-hour darkness, there's no real, you're not going to get a view out of your window. It's not going to provide any natural daylight. So they've adapted. They have rooms without windows. But that also means that there's the opportunity with the aurora australis. That's something that Kellert didn't talk about, either aurora borealis or the aurora australis. And can you provide opportunities to interact with that? And so that got me this chart, so some of the emergent patterns, the primary one of why things didn't get included was the climate. I mean, when this is what you're looking at for the continental plateau, it's not a familiar climate to most of us. So it's not necessarily something that you want to engage with. It's not something that you're going to incorporate and bring into your space. It also prevents the inclusion of more familiar climates. You can't have a green facade. You can't have a green roof. You can't have waterfalls. They're going to freeze. It's not going to end well. So that was the first pattern that came out, that emerged, that was most prevalent of what you couldn't do with the spaces, just purely due to the climate itself. The next one was a lot of the attributes that did get incorporated was purely from standard building practices. So if you're looking at it as a checklist, if you've got a window in the wall, you're going to get natural daylight, you're going to get views. Doesn't matter where you are in the world. So a lot of these buildings are constructed with standard practices. and therefore they're going to inherently automatically have these attributes. A unique aspect of building in Antarctica that I didn't anticipate was that it's a transitory population. There are no permanent residents in Antarctica. This is a photograph of Esperanza Base. This is an Argentinian base. There is a Chilean base that they have tried to have more of a permanent settlement. They've had children born there. They've had marriages there. They are establishments that have schools and a communal system. But even then, people they aren't born and they don't die there. They do leave and go back to their home countries. So regardless, you have this population that has a turnover. And that impacts a number of different aspects of building design. Specifically, think about how initial vernacular architecture has grown and developed over time through societies of permanent human settlements. That, yeah, you put up that emergency shelter, but over time it grows and you develop a language and communal practices around that, and it impacts your architecture. You're not necessarily going to have that when people don't spend more than one season or several seasons within this space. It did, however, create other opportunities of, in itself, it became this ongoing, perpetual, changing culture within the buildings. Specifically in McMurdo, certain areas became affiliated with certain groups, and so that has still continued on with different cultures within the buildings, but it's not the same as what we think of. That has also led to more opportunities for individual customization. So if you're not going to live in your own space for a longer period of time, you aren't going to make permanent changes to your personal space. And so with Admonson Scott and Halley 6, they took that into consideration and they provided opportunities within the space to facilitate temporary customization. Now, the largest factor that I found was the age in identifying patterns. The most significant is the ATS, the Antarctic Treaty Secretariat. So with the conclusion of the International Geophysical Year, they developed the ATS, a governing organization for Antarctica. So no one country has control over it. It's this council or secretariat that initially 11 countries were members of. It's grown since then. Those 11 countries were countries that participated in that first IGY, and they had specific voting privileges that other countries have since been able to include, or you can just be a member, just not a voting member. This creates the structure and the organization for Antarctica, and specifically the Madrid Protocol, which was passed in the early 90s, impacts the buildings greatly, and what can be and can't be included, specifically with the biophilic design aspects. So one thing we think of with Antarctica, especially with the heroic age, is the inclusion of huskies or ponies. Ponies aren't quite a smart choice to include, but that happened. Now with the Madrid Protocol, you can't bring alien or exotic animals into Antarctica. So that whole category of animals in biophilic design is now challenged. You also can't go up and pet a penguin. You have to wait for a penguin to approach you. So you can't really keep a penguin around for your own personal animal access. So now you have to look at how you can interpret these in a secondary nature. You can't have that primary contact. Similarly, there is a significant challenge with bringing in plant life. The majority of the contemporary stations either plant for or have a hydroponic chamber. Not only does that help provide food, but it also provides greenery and just a feeling of what the occupants associate with nature and home. And that kind of shows that stark contrast between incorporating nature that you are familiar with from your source country or incorporating nature from Antarctica. Antarctica does have plants, but they're lichens and mosses, which I'm not sure many people would really get the same reaction to that they would a tomato plant. And therefore, these hydroponic stations have fulfilled part of that gap, but it's very difficult and there's very narrow parameters around what can come and make sure it doesn't get outside of the station. These are all to help protect the environment of Antarctica. So you don't get invasive species. It's also cut down on how we approach our buildings when we abandon them. The earlier structures had this sprawl around them. And you can even still see that with McMurdo, where it grew out and now it's condensing in. There's a new plan to redo the station in an even more compact. We're trying to lessen our footprint in Antarctica with our buildings. And so the Madrid Protocol also dictates that. And why I use McMurdo as an example is with its partner, Casey Station. Each time they changed, with Wilkes Base, the Madrid Protocol wasn't in place, and now it's considered a historic structure. It's not preserved yet. They need to get to that. That has domain issues of who's responsible. But when they left Repstat to build the contemporary Casey Station, they had to dismantle Repstat. There's some argument that that was historic and it should have remained because it shows an important part of their building history, but they cleaned it up. They shipped everything back to Australia to be disposed of. So you didn't end up with this sprawl around it. So they're just trying to minimize the footprint and the impact on Antarctica and have a more cognizant presence there. And also building technology. The building practices at the time of the heroic age was much simpler. Even though they might have had more technologically advanced practices back in their home country, but they weren't able to do that in the Antarctic environment. And so we have these more rudimentary huts, wooden huts. In contrast to what we have today and what is proposed, which are much more futuristic and some might say much more removed from nature, where you were much more aware and nature was much more present as an impending doom sometimes. Within the huts, these new stations and new structures, while more efficient, separate the occupants more from the natural environment. The technology around how we get to Antarctica has changed. This was the technology during the heroic age with the Terra Nova. Versus now with the Aurora Australis, Australia's primary ship to get down, or with US Air Force Hercules aircrafts. So this allows us to get more supplies and building supplies down more readily than the earlier ships allowed. One thing that I think it was New Zealand experienced this year, might have been Australia, but they had a problem with their runways. They couldn't land the airplanes because of the warm environment, because of the temperatures rising. The runway became too spongy. And so we might have to go back to relying on primarily by ship. However, I know Davis Station for Australia is looking at doing the first paved runway in Antarctica. We'll see how that goes over. And then the final and most critical shift that I saw with these stations is the prioritization of the occupants' well-being. With the initial stations and the majority of the IGY, these were shelters. We started to look at, how can we make people happier in the shelters, but the primary function was purely shelter from the elements. With Adamson Scott, and especially with Halley 6, we start thinking about the occupant well-being, their mental and physical well-being within these beyond just purely shelter. Specifically with Halley 6, the inclusion of colors to enhance and create a dynamic and stimulating environment when one looks outside, especially on the continental plateau or ice shelves where you're completely surrounded by flat white. So you want to have your interior environment help stimulate and keep your occupants happy. So those were my primary findings with my research. I think I've seen a couple of things pop up for questions.
Yes, we do have some questions. That design as holistically sustainable. What does the process entail of transporting the architectural and construction materials to the Antarctic sites, which you did touch on, either first by ship, then by plane? Moreover, what measures are being taken to make this transportation process more sustainable? Do you have any answers for that? No.
Building doesn't happen just on a willy-nilly basis. Creating a building, and oftentimes, like with Halley 6, it was completely constructed in South Africa as units and then brought to the continent within pieces that were then assembled. And so we aren't, we're making sure we streamline the process, and we're not going to run out of screws and have to go to the hardware store because it doesn't exist. So that's really where we're coming from. And also the Madrid protocol has a lot in place, and you have to have a comprehensive environmental action plan in place prior to construction, and it all has to be approved by the APS. So there's a lot of layers involved. The McMurdo station has been under review for this new station for quite a while, and so it takes a while. So they try to think it out pretty well before they get to that point, and whether or not it's truly necessary.
Great. Another question from Stephen. Perhaps I missed this point. Since Antarctica has varying light exposure lengths during the year, has oscillating blue reduced and blue enriched lighting been incorporated into the designs?
Not that I found. They are starting to have light simulations, so you can set your own false dawn for your alarm clock. That was met with varying success. A lot of people bring their own down, but I haven't seen that being implemented yet.
Okay, a couple more questions from Stephen. Regarding the ATS, when you mentioned the Madrid Protocol, it reminded me of the Madrid system of WIPO concerning industrial design and patenting of mechanism, aesthetics, or novel characteristics. Concerning mechanistic styles for the purpose of surviving extreme environments, if you submitted an application for intellectual property of an industrial design, would you be able to submit it as originating in Antarctica, or would you submit it as an American researcher for the purpose of using in the Arctic? Could a patent be registered in Antarctica? It's a good question.
That is a great question. I'm not sure.
It's a great answer. Someone must know the answer to this.
That gets tricky because while the ATS doesn't recognize the sovereignties, they still exist. And this became an issue a couple years ago when you had the murder at the Russian station, or the attempted murder at the Russian station. Who had jurisdiction?
Ooh. All right. Another question. It says, could UNESCO make that first cabin shelter establishment a protected World Heritage Site, or is that where domain issues occur?
There are independent heritage sites, and both of those structures are under the heritage sites. Mawson's Hut is overseen by the Australian Antarctic Division and Mawson's Hut Foundation, and the Terra Nova is under the Antarctic Heritage, New Zealand Antarctic Heritage.
Cool. We have a couple questions from Paula. The first one is, how close are these structures located to each other?
The two closest are Terra Nova Hut and McMurdo. They're on the same island. But I tried to get a spread around the continent as much as you can. So they're mostly around the periphery, except for Edmondson Scott, which is dead center.
Cool. Paula also was wondering, she missed what changes were made to the dome roof with the snowdrift problem.
They got rid of it. They maintained it while they were building the new station, but they've gotten rid of it. They kept some of the support spaces that were below ground or below the snow, but the dome they dismantled. Part of the Madrid Protocol, they dismantled it.
Cool. Sorry for the giggle. We have an anonymous attendee that asked, can you tell us more about the murder?
Actually, it's horrible, but it's somewhat amusing. So Russia, the US, Britain, and Australia, the practices I know, they won't let people winter over more than twice, and Russia has a different practice. So these people had been with each other for over a year, And it's a small community, and one guy kept ruining the ending of the books for another guy, and he just snapped and stabbed him.
No.
They separated them. The guy did not die. I'm not sure the court proceedings.
Wow. That's okay. Yeah, don't ruin the ends of books for people.
No.
That's a good moral.
It's somewhat justified. I
mean, oh, I kind of agree. Oh, that's great. Let's see. I don't see any other questions coming in. Oh, we have a comment from someone. Okay, from Nikki Rhodes. I can't help but see a comparison between Halley 6 and Archigram's Walking City from 1964. Outside of Antarctica's climatic context and constraints, there seems to be an element of blank canvas architectural creativity that nonetheless attempts to respond to the greater architectural canon. What are your thoughts on this connection?
Definitely. So Halley 6 was a unique opportunity that the British Antarctic Survey took, where they held an architectural competition for it. And that's part of why you see much more playful and experimental versus more pragmatic and almost institutional. And that is definitely where the shift of all the newer stations, not just that Hugh Broughton Architects who won that, they now do almost all the stations. They've brought that more playful sensibility. They pulled strongly from some sci-fi show from the 60s. I can't think of it at the time right now. But they definitely pulled from like sci-fi 60s television shows with their design, and that was part of what won them over with the client.
That's awesome. Definitely reminded me of some Star Wars-esque stuff, that's for sure. Well, there are no other questions coming in, just a lot of thank yous. Thank you so much, Katelyn, for this presentation. It was really very insightful. Oh, we do have another question.
Okay.
It was very insightful. One more question and then we'll call it because we are close to 8 o'clock. Ray asked, to what scale do you see some of the major design features in these various case studies being applied to locations elsewhere with similar colder climates?
But that was part of why I chose Antarctica. Is it's not too far off from Vermont or where Vermont seems to be headed. I mean, we do not have the extreme winds or the extreme cold that Antarctica has for the prolonged period, but we can extrapolate some of these elements and incorporate them here, especially where we've got nature that's more readily accessible that we like. We don't want to shut out. So we can look at this extreme case study and interpret it for us in a colder climate for wintertime. So I know regularly when I check the temperature, granted we're opposite seasons, but we're close through the edge seasons. Their fall and spring are very similar to our winter, and so we can still learn from it. And that's part of why wanting to be firmly Vermont, but part of why I chose the Antarctica too.
That's great. I'm really curious what kind of house you designed for yourself in Vermont. What features you would use.
I like historic houses.
That's its own problem.
Yeah.
Well, once again, thank you so much, Katelyn. This was so cool. I can't wait to talk to my friend who was at McMurdo last year and see what they thought of it, of the lived experience of it. And then next week, same time, we have our last installment of the speaker series for this year. We're going to have some folks that are involved with Design Build Bluff out in Utah. which Design Build Bluff is now part of Yestermorrow. And we're very excited about the programming they're doing with the University of Utah and the Navajo Nation. So tune in for that one for sure. And if you have any people in your circle that wanted to watch this tonight, but for some reason couldn't tune in, it's going to be on our Facebook page and also on the Yestermorrow YouTube channel within the next couple of days. So thank you, Katelyn. And I can't wait to see what your research turns into in another 5 years.
Thanks. Thank everyone for coming.
Have a good night.